Today's demo highlights how Rampart Recon protects and tests agentic systems. Agentic systems behave very differently from traditional applications, which means they require purpose-built protection to ensure they operate exactly as designed. In this demo, we'll focus on three core interaction layers unique to agentic systems. First, host-level interactions. Rampart ensures the agent uses only approved tools in a logical sequence and with the correct privileges. Second, interaction with the foundation model. Here, Rampart applies tailored guardrails to control how the agent communicates with the LLM. Third, interaction with tool servers. Rampart protects the MCP interface, preventing access to unapproved or unsafe tools. Agent identity itself is handled by enterprise-grade commercial identity providers and sits outside the scope of this demo. The demo is centered on an agentic e-commerce application and is designed to highlight Rampart's ability to detect anomalous behavior. These detections can also be configured to actively block or prevent actions in real time. Let's walk through how it works. Let's start with an agentic checkout experience, the next evolution of shopping. We begin with a simple prompt. Find amber fossils from a specific website as a gift for a friend with a budget under $250. The agent activates its product discovery tool, scanning the site and returning a short list of relevant options. We select option 4. The agent then finds the recipient's shipping address from approved contacts and confirms it before proceeding. Next, the customer chooses and verifies a payment method. With a final human approval, the agent generates a secure payment link and completes the order. Along the way, the Rampart interface captures key events. We see the use of the OpenAI GPT 5.1 model. We observe the model processing tool calls, hitting the MCP endpoint and receiving responses, showcasing semantic understanding. A full tool call list is recorded, representing requests made by the agentic backend. In this instance, everything operates within expected bounds, establishing a baseline for normal agentic behavior. Now let's look at an off-topic or misuse scenario where a user attempts to misuse, trick, or jailbreak the foundation model. In this example, the user asks the system to do their math homework, a request clearly outside the scope of the shopping experience. As you can see, the model initially attempts to respond. The web application firewall detects the off-topic request and generates an alert. This is critical because the WAF understands the intended goals of the application, allowing it to detect off-topic behavior and jailbreak attempts. In production, this type of request can be blocked automatically with a safe response such as, "This is outside my area of expertise. Can I help you with your purchase?" In this next scenario, we focus on the security of MCP. We ask the system for a list of MCP tools. The agentic system returns a large amount of information that, if examined closely, could be used maliciously. What we're seeing isn't just a list of tools, but guidance on how to use them. While some protections are in place, an operator could still receive tool details, usage instructions, and hints that could be exploited for unintended or harmful purposes. Rampart identifies this as malicious user input, a bad prompt. Next, we leverage the MCP information to exploit the application. Now that the tools are exposed, watch how the system can be misused. The user attempts to validate contact information using a tool intended only for a checkout workflow. This is a bad tool call, one that should never be invoked directly by a user. Rampart's insights correctly flag this malicious activity, including a full stack trace of the event. This showcases Rampart's detection capabilities. And beyond detection, Rampart automatically blocks these actions at machine speed, before risk becomes impact. This behavior is also detected by Rampart as a dangerous call, executed outside the application's intended scope, and is stopped. As you saw, Rampart Recon detects issues in agentic systems with no prior knowledge of the attack. This is critical because new attack techniques can be created easily, and defenses must respond at machine speed, rather than relying on generic enterprise-wide guardrails. Rampart's superpower is its deep understanding of the application as a whole. It can accurately identify abnormal activity at machine speed and keep your application running through unknown attacks.